Limit and continuity. Limits have the idea of approaching. For example, let's say a function f(x) equals to x squared minus 1 divided by x minus 1. At x equals to 1, substitute x is equal to 1, we have 1 squared minus 1 divided by 1 minus 1. We get 0 over 0. This is what we call as indeterminate form. It cannot be determined. But somehow, we can approach this function at 1 from the left hand side and right hand side. From left hand side, let's say we started from point 9. Slowly we approach 1 from point 9 until point 99999. And then from the right hand side, we started from 1.1. We can slowly approach to 1 until 1.00001. So what will happen when the x slowly approach 1 from left hand side? Let's substitute all these x into fx. When x is 0.9, you have 1.9. This is 1.99, 1.999, 1.99999. So from what we have done just now, we can say as x slowly approaching 1 from the left hand side, we use negative sign to represent left hand side. Fx is approaching to a whole number. That whole number is 2. As 1.99999 is very close to 2. Then what happened to opposite sign? When we substitute 1.1 into this rational function, we will have 2.1, and then this is 2.01, 2.001, 2.0001, 2.00001. Then we can say as x approaching to 1 from the right hand side, we use a positive sign to represent right hand side. Fx is approaching to a whole number that is 2. As you can see, 2.00001 is very close to 2. In mathematics, approaching can be represented by limit x approaching to 1 left hand side fx. The fx is approaching to 2. For the right hand side, we can say limit x to 1 to the right hand side of function fx is very close to 2. Overall, we can say when x is approaching to 1, that means left hand side and also right hand side, fx is approaching to 2. In mathematics, it's written as limit when x approaching to 1 for this function is equals to 2.